Hello everyone, today I'll be talking about the second year mechanics topic, dynamics of rigid bodies. Rigid body dynamics, as the name suggests, is a study of bodies that are in motion. In this video, we are particularly interested in the effects of external forces on the motion of a body, more so its linear and angular accelerations. The most important assumption in this whole video is the fact that the body is rigid, implying that it does not deform due to the effects of external forces. Deformation is something we will explore later on in our degree. We will be using Newton's second law of motion, F equals ma, and the dynamic moment equation, either m equals I naught or Ig alpha. The following slide consists of an example problem that I will run through on the whiteboard. This example very nicely explores the concept of rigid body dynamics. Please have a look at the question so that you can fully understand what it is asking. We begin by taking the moment of the body around point G. This allows us to get the angular acceleration of the body as it rotates around its point G. You can see on the whiteboard here that I have taken the sine and cosine components of the two external forces, Ff and Fr. This gives us a moment of around negative 1920 newtons. Keep in mind that the question gives us the value of Ig. This means that we can simply find alpha by just doing mg over Ig. This gives us an answer of roughly minus 4.265 times 10 to the minus 4 radians per second, i.e. the angular acceleration of the body around point G is around minus 4 times 10 to the minus 4 radians per second. We now move on to finding the linear acceleration of this body at point G, i.e. its center of mass. We do this by using Newton's second law of motion, F equals ma. But first, we need the magnitude of F. We start by analyzing the forces acting in the x direction on the body. We do this by taking the cosine component of Ff and the cosine component of force R. This will give us a value for the total force acting on the body in the x direction. Now we need to find the summation of forces in the y direction. To do this, we take the sine component of force F and the sine component of force R, and we also add in mg, the force due to gravity. However, if you recall in the question states that we must neglect the force due to gravity. This means that mg essentially becomes 0. This also means that now we are left with just the sine components of Ff and the sine component of Fr. Doing this calculation gives us the summation of forces in the y direction. We now have the summation of forces acting on the body in the x direction, the summation of forces acting on the body in the y direction. This means we can now compute the magnitude of force acting on the body. We do this by taking the square root of fx squared plus fy squared. This gives us an answer of roughly 6,048.79 newtons. Now that we have the magnitude of F, we can use the formula F equals ma to find the value of A. Keep in mind that the question has given us the value of m. Now we can say that A is simply the magnitude of force divided by the mass of the system, or the body. This gives us an answer of 0.112 meters per second. This is essentially the acceleration of the body at its center of mass, point G, and this completes the question. So to recap, we approached this question by drawing a free body diagram that simplified the system. This made our analysis easier and less complex. We then focused on two equations we use in rigid body dynamics. They are F equals ma and the moment of inertia equation m subscript g equals Ig alpha, where mg is the moment about point G. If the body is rotating about a point P, the equation simply becomes mp equals ip alpha. If the body is rotating about a fixed point, we need to use the parallel axis theorem to find the moment of inertia around that fixed point. This is something we learned in first year. Also, if the body has no angular acceleration, we can simply use m equals mad, where d is the distance from the point of rotation to the center of mass of the body. This essentially covers the topic of rigid body dynamics, and I hope this tutorial has helped you understand this topic more. Thank you for watching.